Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we're looking at Unit 17. I'm going to be introducing you to a number of very important terms that we deal with often in plumbing, including offset, diagonal, rise, and run. These are terms that you need to understand as we do calculations for offsets, to be able to move a pipe around an obstacle. So as we calculate and as we describe to others our calculations, it's important that we understand these terms. Let's start with trying to describe what is an offset. We use that term all the time. I need to offset this pipe. But what does that mean? Have a look here in the book. It says when two pipes are parallel to each other. That means they're running in a line, but they're not running right in line with each other, but they're in the same direction. Then they are an offset distance apart. That means the space in between them is called an offset. They may be horizontal or they may be vertical. So this means we'll refer to an offset whether the pipes are flat or whether they're going up in the wall. Check out these diagrams. Pipe A is parallel to pipe B, and these are horizontal. Pipe C is parallel to pipe D. These are running vertical. The distance between the center lines of the two parallel pipes is called the offset. That is oftentimes what we will measure, and that helps us to figure out our cut. This diagram depicts for us that the offset is the center-to-center length of parallel pipes when they're being connected using two 90-degree fittings. So 90-degree elbows are great for creating an offset. You can move the pipe over and continue running in the same direction, but there are other fittings available, and when we're not dealing with 90 degrees, things change a little bit. Examine this diagram. If two parallel pipes are connected by fittings other than 90s, like we're talking about, maybe they're 45s, 60s, 22s, whatever, then the center-to-center length of the connecting pipe is the diagonal. You can see how this cuts across from one fitting to another and creates a diagonal line. The name comes from the diagonal of the square or the rectangle as shown. Now the reason that we would prefer to create an offset with fittings other than 90s and create a diagonal like this is because 90s create more of a restriction of the flow inside of the pipe. So if you can put 45s in, that fluid is going to move more easily through there than if it's pushing against the wall of a 90. Let's talk about these terms rise and run. Rise and run are the same distance. Well, that can be really confusing. That's what it says in the book, but they're not always going to be the same calculation. What it means is they're referring to this other side of a triangle that is not the offset. So it says the figures show how the name changes. For a parallel vertical pipe, there is a rise. So let's look at this diagram on the left. You'll notice we have parallel pipes starting at the bottom. There's a diagonal that moves across, and then it straightens out and continues to go in a vertical direction. The offset is that distance of center line, and the diagonal is the line of the pipe. That's where we're going to make our cut, and we're going to install it along the diagonal. But this does create a triangle, and on the right side we see the rise. There is a difference on that. Let's look at the diagram on the right. this is horizontal pipes. We can see it coming across from the left on the bottom, and then a diagonal moves it up. We're coming up vertically, and then it flattens out again. Our diagonal is our pipe that will connect between those fittings. The offset is the center line difference between those two pipes. And here we have the run. Now what the book is saying is that in a triangle, these are basically the same thing. That does not mean their calculations would always be the same. But please remember, a rise is referring to that difference when you're dealing with vertical. And that makes sense because you rise up. And a run is referring to the difference horizontal. Yeah, as a memory trick, of course. I've never seen anyone run vertically. You run in a horizontal direction. So it's the run. Great. The sample problem in Unit 17 asks us to draw several diagrams, and we have them illustrated here. And they say, why don't you create a diagram for horizontal pipes and for vertical pipes using 60-degree angles. They're asking us to draw out a rectangle and label each part. You can examine these and I can examine these. And it says use a protractor to measure the fitting angles. And let's plan to move on to Unit 18, where we will really start having some fun using what we've talked about to calculate for offsets.